So, good evening, everyone, and welcome to this lecture. This is lecture number 10, and we are dealing with dielectric. And in all probability, we will try to finish this part today in today's class. What we had done in the previous class, we had seen what happens when dielectric is inserted inside a capacitor. Do you remember what happens when dielectric is inserted inside a capacitor? Tell me fast. Do we remember this? What happens when a dielectric is inserted inside a capacitor? What happens when a dielectric is inserted inside a capacitor? Yes. No one remembers it. What happens when a dielectric is inserted inside a capacitor, beta? No one remembers it. Okay, I'll give you 5 minutes. Go through what we had done, what we discussed in the last class, and we will proceed. 5 minutes. Go through what we done in the last class. Then we begin. So, what we were discussing in the last class? What was the topic of the last class? We were discussing the effect of dielectric on the capacitance. What happens if you place a dielectric inside the capacitor plate? What happens? Yes, tell me. What happens?
Becomes k times of the original value.
Capacitance becomes k times than the original value.
Great. The capacitance becomes k times the original value. And then we had seen that it can be done in two ways. The first way is battery removed, and the second way is battery connected. We have also seen that what happens in the case of battery removed. In case of battery removed, charge remains same. Potential becomes 1 by k times. Energy becomes 1 by k times, and electric field becomes 1 by k times. Do we remember this? Have you gone through this?
Yes, sir.
Then if we do the same thing with the battery connected, Abhiram, then what happens? If the battery remains connected, the charge on the capacitor becomes k times. The potential difference remains same. Electric field remains same, but the energy becomes k times. Do we already remember it now? Yes or no? No, yes.
Yes, sir.
And we have also seen that if nothing is mentioned in the question, nothing is mentioned in the question, they don't tell you whether the charge is, whether the battery is connected or the battery is not connected. You will always take it as battery disconnected. Do we remember this? Because in the question that are going to appear in your exam, it may not be given. Do we understand this? Yes or no? Okay, then this is a question whose answer I would require from you. A parallel plate capacitor is immersed in an oil of dielectric constant 2. Dielectric constant is 2. What happens to the electric field between the plates? What happens to the electric field between the plates? And there are options given, and I hope that you can give me the answer of this one. What will be the answer for this one? Anyone? Anyone? Can you tell me what is going to be the answer for this one? Here nothing is mentioned, so what will we assume? What is connected or what is not connected? What will we assume here? Which case is this? Case number 1 or case number 2, beta?
Sir, option B.
Option?
B.
Option B. Why is it option B, beta? Tell me, why is it option B? Why is it option B? Why is it option B? What is the answer? No one knows the answer? Okay. The correct answer is which one? The correct answer is option B. Why it is option B? This is the case. Nothing has been mentioned here. So we will assume that this is the case where battery is removed. Battery is removed case. This is the case where battery is removed. Do we understand this?
Yes, sir.
This is the case where battery is removed. Dielectric is inserted. Capacitance will become 2 times. Charge will remain same, but the electric field will become half. Yes or no? We understand this?
Yes, sir.
That is what we need to understand in this question. And these are the type of questions that are going to appear in the exam. Are we ready for them?
Yes, sir.
Yes, sir. Then, sir, this question, sir. This question, sir. Give me the answer fast, sir. The question comes on your screen, sir. Now, sir. Tell me the answer now, sir. What is the answer, sir? Yes, sir. When air in the capacitor is replaced by a medium of dielectric constant K, what happens? What happens? What happens? What happens?
Sir, B.
Increases K times the capacitance becomes K time. Do we understand this?
Yes, sir.
Great, great, great. Okay. Let me see. Let me look for more question. Okay, this question will test everything that we have learned. Remember, the more the number of questions that we are going to do, bacha, the better we are going to fare up in the exam. This is the next question, bacha. Can you give me the answer? The capacity and the energy stored in a parallel plate capacitor with air is C naught and W naught. If air is replaced by glass whose dielectric constant is 5 between the plates, the capacity of the plates, capacity means capacitance, the capacity of the plates and the energy stored in it will be how much? Remember, also here nothing has been mentioned. Nothing has been mentioned. Nothing has been mentioned. So we'll have to take it as the case where the battery is removed. Can I have your answers, please? Which is the correct option, my dear friends? Yes, bacha.
Sir, option B.
Option B is the correct answer, my dear friends. Capacitance becomes 5 times K times, whereas the energy becomes 1 by K times. Do we understand this? Yes or no? No, yes. We understand this? Okay, now we are getting in the groove, it seems. Well done. This is the next question, my dear friends. Question based on knowledge.
Sir.
Knowledge. This one comes on your screen now. The dielectric constant of an insulator cannot be how much? How much? How much? Yes, bacha. What is the correct answer for this one, bacha?
Option B, sir.
The dielectric capacitor of an insulator cannot be option B 6. Why it cannot be 6? What is the correct answer here? No one knows. That's very sad. That is really very
D.
D. Why it cannot be infinity? Why it cannot be infinity? Who has got the dielectric constant K as infinity? What do we call them? Who has got the dielectric constant? For which body is the dielectric constant infinite? Yes, bacha. Anyone remembers it? No one remembers it. That's not a good sign. It is for conductor, Abhiram. Well done.
So it is always or equal to 1. Greater than or equal to 1.
It lies between 1 and infinity, my dear friends. You have written this. I don't know what you write, what you are doing. It's really very sad for me to say this. You have written this. No one remembers it. I don't know what you write, how you write, if you write, do you read it? I don't know that. I will pray to God that everything gets good. You've written this, I have given you this, I don't know why you don't write it. Anyways, I can't do anything much on that. I can only request you to please go through the notes and read them. And please remember them. Sincere request from my end. If you could remember things, that would be good for your own self. Anyway, that takes me to the next question. And this is the question: when a slab of dielectric material is introduced between the parallel plates of a capacitor which remain connected to a battery, remember, they remain connected to a battery, then charge on the plate relative to the earlier charge, what happens? What happens? Which one is the correct option? Which one is the correct option? Can I get an answer here? I'm waiting patiently for an answer. Whom should I look for an answer? Who is going to give me the correct answer? I'll give you 2 minutes to think about it. Are giving me the correct answer. It will be more charge. When the capacitor is connected to the battery, charge becomes K times voltage and electric field remains the same. So that is what I was looking for in the answer. And I hope we have understood this. Yes or no? No or yes?
Yes, sir.
Pakka?
Pakka, sir.
I don't trust you anymore because you don't remember simple things, beta. I am very disheartened. Anyways, let me see if you can give me the answer for this one. Remember, one of this question is going to appear in your NEET. One of this. If it comes from this topic, one of this is going to appear in your NEET. And this is the next one in line, my dear friends. Next one in line, next one in line. An air capacitor. What do you mean by an air capacitor? By an air capacitor, we mean a capacitor which has air in between the plates. Is connected to a battery. Good. The effect of filling the space between the plates with a dielectric is to increase what? I'll give you 2 minutes to give me the answer. Correct answer, no thinking answer. But yes, that is the correct answer. Option D. The plates are connected to the battery. When the plates are connected to the battery, the charge becomes K times. At the same time, dielectric is inserted, so the capacitance has to become K times. That is absolutely correct. Everyone understand this, or this is going above our heads? Saying bye bye, bye bye, bye
Understood,
bye,
sir.
bye bye. Yes?
Understood, sir.
Understood, sir. One more, this one. And I would be very glad if you can give me the answer for this one. I give you 2 minutes to do this. In any ways. So this is the next question, sir. The intensity of electric field at a point between the plates of a charge capacitor. So this is the capacitor. They're asking about the electric field at any point inside the capacitor. What is the correct option? And I'll give you 2 minutes to give me the answer. And just what answer you were saying, beta?
Option B, sir.
Option B. Abhiram is correct this time. It does not depend upon the distance between the plate. It is constant. Capacitance is inversely proportional to the distance, not the electric field, my dear friends. It does not depend on the distance between the plates. Remember, electric field between the plates of a capacitor is constant. It does not depend on anything. It only depends on what is the charge on the plates, nothing else. So please remember it and do not forget it. Let us move ahead in and do some more things that we have to do. Now, the next heading is capacitor partially filled. Capacitor partially filled with dielectric. So up till now, what we were seeing, my dear friends, was a capacitor was filled completely with a dielectric. Now what we are going to see is a capacitor which is partly filled with a dielectric, not completely filled with a dielectric. Now, what do you understand by partly filled? Now, there are different ways in which you can have this capacitor partly filled. So, we will do it case by case. Case number A. Area of dielectric is same. Area of the dielectric is same. That means it occupies the entire area. It occupies the entire area. So how is this dielectric filled? So this is the diagram. First listen to what I am saying and then you will draw and write things. So this is how the dielectric is filled. We have a dielectric, let us say this pink dielectric. I hope you can see this dielectric. I'm coloring it with pink. This pink is your dielectric and this dielectric is placed inside the capacitor like this. Now this dielectric is not completely filling up the space. Let us say the dielectric constant is K and let us say that the thickness of the dielectric is T. So that would be given to you. The thickness of the dielectric would be given to you and the dielectric constant would be given to you. Now, how does it affect the capacitance of the capacitor? That is what you will have to answer. If it is completely filled up, that capacitance will become K times, but here it is not completely filled up, it is partly filled up. So what are the things that you need to remember? The first, obviously, is the original capacitance. Original capacitance will be epsilon naught A by D. Do we remember this formula of original capacitance? Epsilon naught A by D. Yes or no? No or yes? Do we remember this formula of original capacitance of a capacitor, epsilon naught A by D? Abhiram remembers it. What about the others? Do we remember it?
Yes, sir.
This is the original capacitance. Now, if I call the new capacitance as C dash, remember the formula for new capacitance, it is epsilon naught A upon D minus T plus T by K. This is the new formula of capacitance. This is the new formula of capacitance. Capacitance has changed. Now you can also find the ratio and remember this ratio C dash by C. Oops, I'm writing C1. C dash, the new capacitance by C, you can divide it. And what will you get? You will get it as like this, D upon D minus T plus T by K. Remember, it's a very important ratio that you will have to remember, bacha. Please remember it and keep it with you. Now, one more point you will have to remember. I will write it and then I will give you time to note this down. This capacitance does not depend on this capacitance when this dielectric is inserted. It depends on T. What is T here? What is T here? What is T here? Can anyone tell me what is T here? T is the thickness of the dielectric slab. Well done. And it depends on K. What is K here? What is K here? What is K here? K is the dielectric constant. It depends on these two factors. Remember, this capacitance does not depend on, very important point, does not depend on position of the dielectric, where it is placed. You can place it in contact with the first plate, positive plate. You can place it in contact with the second plate, negative plate. You can place it anywhere in between. It does not depend on the position of the dielectric slab. Will you remember this? Now I will give you
Yes,
2 minutes to write this everything down. Everyone has understood this?
Yes, sir.
Okay, so please note it down. I'll give you 2 minutes to note it down. Then let's move on and do the next part. Now, let us first do all the cases so that you will get today's day and Sunday also to go through them so that we can solve the problem on Monday. Now, this is only one dielectric put like this, but there may not be one dielectric. There can be more than one dielectric. So, this was in case number A. This was case number A and condition number 1, where you have only one dielectric. Now let us move on to subcase number 2. In this subcase number 2, what are you going to have, my dear friends, is you are going to have more than one dielectric put. And then, so this is the condition here, my dear friends. This is the condition here, my dear friends. Case number 2, we have more than one dielectric, K1, K2, K3, K3, and so on. A large number of dielectrics put. One of them is K1, thickness is T1. Please first understand, then you write. One of them is K2, thickness is T2. One of them is third one is K3, thickness with it is written T2, it has to be T3, and so on. Now in this case, what is the effective capacitance? If you just remember the first formula, you can remember this formula as well. You just keep on piling up that formula, and you get this formula, this formula, this formula. And I hope you can remember this formula which is coming on your screen now. You can remember this formula, yes or no? When there was one plate, it was D minus T. When there are more than one plate, it is D minus in bracket T1 plus T2 plus T3 and so on, plus T1 by K1 plus T2 by K2 plus T3 by K3 and so on. Do we understand this? Yes or no? No, yes. Will you be able to remember this formula? Please tell me. So the original formula is epsilon naught A by D. Again, I will write it. And the new capacitance C dash, I can write it as epsilon naught A upon, I will just write it in the terms of mass, D minus summation of T. Understand the meaning of summation of T? You add up all the Ti, T1, T2, T3. So this is one bracket plus in the next I have summation of Ti by Ki. Are you able to understand what I'm writing here in short? This is just the mathematical way of writing it. Do we understand this? Yes or no? No, yes?
Yes, sir.
Everyone understands this. Okay. Similarly, I can now find the ratio of C dash by C, and C dash by C will be equal to D upon D minus summation of Ti plus summation of Ti by Ki. Now I will give you 2 minutes. Understand it and then note it down. In today's class, we are going to write all these things. The next class, we are going to solve them. I will give you 2 minutes. Once you are done, please let me know. So that was the case where a large number of dielectric slabs were inserted. There is one more special case in this one. Now, in this special case, and we are going to take example of, let us say, 4 capacitors or 4 dielectrics connected. In this special case, because we have to understand it completely, and therefore I have taken this case of 4 dielectrics. Now, can anyone tell me what is the difference between the previous case and this case? This is subcase number 3. What is the difference between the previous case and this case? Now, don't tell me numbers. They were large number, and here there are small, only 4 numbers. They could be 5 or 6 here also, or 7 or 8 or 10 or 12. What is the basic difference between this case and that the other case? Not the number, not the number of dielectric slabs. Apart from that number of dielectric slab, what is the difference? Can anyone tell me? Apart from the number, what is different? Different dielectrics, there also it was different beta. in that previous example also the dielectrics were different, K1, K2, K3, K4, and the dielectric constants and thickness were also different, T1, T2, T3, T4. What is the difference between this one and that one? Anyone? No one? Well, the difference is in the previous question, if you see, there was a gap between these capacitors, and if you look at this yellow gap, in this yellow gap there was always vacuum or air. There was gap between the capacitors. So basically, a gap between the dielectrics. That means the dielectric, even though there were a large number of dielectrics, there was some air in between or some vacuum in between. But if you look at this combination where I have 4 dielectrics, it is completely filling up the space, not with one same dielectric, but with different dielectrics, which have got different dielectric constant, different thickness, and there is no air gap. There is no gap, no air, no vacuum. Do we understand this? So in that case, the formula starts to look like this, that d minus t, d minus summation of t, because if you add up all this t, t1, t2, t3, t4, it will give you d. So the formula becomes much more shorter and much more easier to remember. The formula becomes epsilon naught a divided by t by k1 plus t by k2, I mean t1 by k1 plus t1 by k2 by t2 by k2 and so on. I still write the original formula. The original capacitance is epsilon naught a by d. The new capacitance, my dear friends, C dash, is epsilon naught a upon, here only I have summation of Ti by Ki. I can write the formula C dash by C will be equal to d upon summation of Ti by Ki. Now I will give you 2 minutes to note it down. Has everyone understood this? So in today's class, we have seen the different ways in which the dielectric can fill up the gap between the capacitor plates. We will do questions based on this in the next class. And we will do one more way of how these capacitors can be filled with dielectrics. We will see those things in the next class and try to finish your chapter by the next class. Everyone understands this? How I'm filling the capacitors here? How
Yes, sir.
dielectrics were filled? We will continue with this in the next class. I hope everyone has understood what has happened in today's class. Take care and God help you all. Bye bye.